All right, everyone. Thanks so much for joining us today for our webinar, Mapping and Tracking Your Users' Crave. My name is Grace McLean, and I'm the Marketing Manager at PubNub. So we're super excited to have our partners with us today, Esri, joining us for this webinar. So we have two of their best developer advocates, Andy and Nick, who will be co-hosting this webinar with me. Andy, Nick, you want to give a shout out real quick?
Hi, this is Andy. Glad to be here.
This is Nick.
And on the side, we have Pubnub, PubNub's solutions architect, who will be joining us online, and she'll be answering questions throughout the webinar. So if you have any questions throughout as we're going, you can just submit a question at the sidebar on the control panel, and she'll be answering those for you. Also, after the webinar, if your team has any questions that you might have regarding your company's use cases that can leverage some of our real-time technologies that we're talking about today, you can always reach out to Bob now or I. So let's get started. As I said, I'm Grace, we have Andy and we have Nick here with us, and we're super excited to be joining you guys for our awesome webinar today. We've got an exciting agenda that'll start with me giving a short introduction to PubNub. Andy will then be giving an introduction to Esri's ArcGIS software, as well as diving into the cool Esri blocks that they've been building using Pubnub Functions. Nick will then take over for a technical demo that showcases the power of PubNub and Esri's blocks, followed by a quick recap of the PubNub-Esri partnership. Last but not least, we'll be saving the last 15 minutes for a Q&A. As a reminder, though, Bhavna is still going to be online and answering questions throughout, so feel free to shoot them her way. So let's dive in. So let's talk a little bit about what's driving the demand for real-time connectivity today. So real-time functionality has now become basically a standard of the most successful apps we use every day. So popular apps like chat and social apps, ride-sharing, multiplayer gaming, and even IoT are all powered by real-time data streams. So customers expect real-time interactivity, and because of that, developers are also required to build it. Real-time interactive mapping is one of those features that users have come to expect, and we'll talk more about that today. One of the most popular examples is Uber, which showcases cars moving in real time, and that's just one example of real-time mapping in action. A little more about background on PubNub. So we enable developers to easily and securely build scalable real-time mobile, web, and IoT apps via a globally distributed real-time data stream network. You can think of PubNub as a global content delivery network, or CDN, but for the streaming web. Whereas a CDN is designed to serve static content for data at rest, a data stream network is optimized for serving dynamic content or data in motion in real time. The DSN architecture.
Grace, it's Nick. Sorry to interrupt you. I'm only seeing the opening slide here, and I think Bhavna is also.
Oh.
I don't know if that's anything you can fix on your side.
Yeah. It says I'm the presenter.
Huh.
Hold on. Just a second, guys, while we address some technical issues.
Much better. We see the slides now.
Awesome. So you guys can see the slides?
Yep. Yeah, better here now.
Okay, awesome. Sorry about that, guys. So why don't we just dive right in? I think for the most part, just a quick recap since you missed out. I want you guys to see our lovely faces. So that's me, Andy, and Nick. Are a little bit more about our agenda today. And then I'll dive right back into about PubNub. So as I was saying before, the DSN architecture was built as a network, not as a single cloud solution. So it allows PubNub to deliver unmatched speed, reliability, and scalability. PubNub is also programmable, meaning you're able to compute on the network layer. So a developer can implement their application or business logic directly onto the PubNub network and have it execute on data streams across all of PubNub's global edge locations, while also maintaining a real-time experience. PubNub is delivered as a service, so there's no need to build or maintain the backend infrastructure. Developers are free to focus on building the best apps and getting it to market faster. All right, you guys able to see this slide?
Yes.
Awesome, cool. So I want to tell you a little bit more about our newest feature, Pubnub Functions. So it's serverless compute at the edge of the network. With a click of a button, each function is deployed globally to every point of presence in the network with a guaranteed sub-10 millisecond time to execute. Functions are also backed by PubNub's 5 nines SLA, scale as needed, and you only pay for what you use. Unlike many stateless compute environments, PubNub Functions comes with a global key value store for keeping application state in high performance. PubNub Functions allows developers to quickly build and execute innovative real-time capabilities. With functions, developers can quickly do 3 things that I think are really interesting. So 1 is transform, filter, aggregate, and reroute data with custom business logic. 2, deploy secure REST endpoints instantly. And 3, integrate third-party services for things like sentiment analysis, machine learning, or geolocation, like we're doing with Esri today. And finally, to kind of give you a sense of PubNub's reach in the market, right now we are connecting 330 million unique monthly devices and sending 2 trillion monthly transactions, all under a quarter second. I mean, that's just massive, massive scalability and speed. So companies of all sizes, whether you're a 2-person startup or Fortune 500 company, and more than 150,000 developers, globally trust PubNub to provide the backbone of their real-time infrastructure, and essentially to become more agile and innovate faster and deliver exceptional customer service. So with that, I'll be telling you, or I'll give the mic over to Andy, who will tell you a bit more about Esri.
Haven't seen the invite yet.
All right.
Okay. Thank you, Grace. Can you see my screen okay?
Yeah, we're good.
Well, thank you. Before we dive headfirst into the interesting code bits, we wanted to introduce you to Esri. We are the world's leading provider of mapping analytics software. Our ArcGIS platform is used every day to literally help solve world problems and provide deeper insight into data for decision makers. And these decision makers range from world leaders all the way to individual business owners. Our software is in use in 137 countries, 75% of the Fortune 500, and in a wide variety of industries, including commercial, such as Starbucks, and I'll get back to that in just a minute, education, nonprofits, humanitarian, government, and many more. So Starbucks is a great example of using ArcGIS. They have over 20,000 locations worldwide. And when they open a new store, they use ArcGIS to provide critical decision-making information to senior managers. This information includes things like retail trade areas, traffic patterns, and super detailed demographic data for population surrounding a potential store location. The software we'll be demonstrating as part of the ArcGIS platform, which is designed from the ground up to provide enterprise geospatial solutions. On the front end, we have custom applications, customizable templates, application builders, desktop software, and a wide variety of APIs. Our geospatial services provide cloud-based access to maps, of course, visualization tools, and powerful geoanalytics. Hopefully, we'll demonstrate to you today that Esri and the ArcGIS platform offers so much more than just dots on a map. Our software is actually used to do some pretty amazing things, from predicting flash floods, cutting off disease outbreaks, solving world problems like poverty and food insecurity, and that's just to mention a few. We believe you'll find a real-time tracking demo just as interesting because it skims the surface of what's possible with our platform, and hopefully that'll spark some ideas and conversation. Our developer portal is at developers.arcgis.com. This site contains all the documentation and downloads for our APIs and SDKs, including REST and JavaScript. We'll be demonstrating those today, Python, .NET, native Android and iOS, and more. You can also create and host geospatial services in the ArcGIS Online Cloud. And we also have these cool dev labs. These are relatively new, and they're 10 to 15 minute step-by-step lessons that introduce you to our APIs. And there are hundreds and hundreds of samples. For example, the JavaScript API, which we're showing today, has over 200 samples by itself. So definitely go check out that site after this presentation. Esri has 4 blocks. These have already been published on PubNub, and you can check them out today. The blocks include driving directions that can also automatically take into account traffic conditions, Geo Enrichment, which gives you programmatic access to detailed demographic information, and we also have geocoding and reverse geocoding. These give you the capability to convert either an address to a coordinate, like a latitude, longitude, or vice versa for mapping and analysis. The last item I wanted to cover before I hand things over to Nick is a high-level overview of our demo and what we've built today. The demo consists of a custom PubNub block and several JavaScript applications. This prototype has functionality for driving directions between multiple pickup and delivery points. That's what we're going to be tracking. And this takes into account traffic conditions, which we think is pretty cool. There's also real-time vehicle tracking, as I mentioned, drive time areas, and geofences. Drive time areas take a location, like where you're at right now, and calculate how far you could get on all the surrounding road networks within a period of time, such as 4 minutes. And you'll see these in use in Nick's demo. Behind the scenes, what we do is we take that drive time area as a polygon and use it in what we call a geofence. When the delivery driver's location enters or exits this geofence, we can programmatically trigger different actions, such as alerting a customer that a delivery is imminent. And now I'll turn it over to Nick. He's going to dive into the technical architecture and start to pull all these concepts together for you. So Nick, I'll now turn it over to you.
Thanks, Andy. All right, so yeah, thanks for the intro, Andy. Thanks, Grace. Let's start off by taking a look at the problem that we're going to solve today. So Andy talked a little bit about, at a high level, about what we're going to be doing and the kinds of things we're going to be looking at. So let's state the problem to begin with. We're going to be building a customer delivery system. So let's say we have a collection of customers. In this case, let's just look at 4 right here. Now, they came in any order. We don't know what order they come in. And we have a delivery truck. And its task is going to be to make the most efficient set of deliveries to those customers in order. So what we want to do is figure out the best route to get to those customers. In this case, we're going to be considering time. So we want to do the quickest route. Now, we could do the shortest route, but the quickest route is typically what people want to do in a scenario like this, especially if you're taking into account traffic and the like. So that's the problem we're solving. How are we going to go about doing it? So we have our players here. We've got the customers, the driver. Now, there's probably going to be some order management system sitting there. We're not going to concern ourselves too much with this, other than to assume that these customers and the order and the deliveries come from some external system. Now we get into the components that we're going to be looking at today. The first bit is the delivery management app. So our order management system is going to send up a list of customers to the delivery management app. Now it doesn't care about what order those customers come in. It's just got a set of deliveries that are on the truck. The next components we've got in our solution are going to be PubNub's cloud and the ArcGIS Online cloud. So there are no servers involved here. We're just talking about cloud solutions, and everything that Esri does with our ArcGIS product is REST enabled. So our communication between the delivery management app and ArcGIS Online is going to be done via a REST API. Now we have a JavaScript API that we're using in the delivery management app that abstracts a lot of that REST API away. And when we take a look at some of the code a little later, you'll see the difference between communicating to ArcGIS Online using the JavaScript API, our JavaScript API, and communicating with it using just raw XHR REST requests, which we have to do from the Pubnub function. So the delivery management app communicates to ArcGIS Online, it gives it that set of customers and the driver, and ArcGIS Online returns with the optimal route considering current traffic conditions. We can also say, well, the driver's not going to leave until such and such a time, and ArcGIS Online can take that into account as well, and we take historical traffic data to build a predictive model for traffic. In addition, if it's a long route, we actually consider the traffic at the time that the driver will get to that point. So that's probably more useful for a long distance drive, but the capability is there. And again, all of that just based in the cloud. So the next component here is the Esri function sitting in Pubnub's cloud. That function communicates to ArcGIS Online to figure out where the truck is in relation to the customers, in relation to a proximity area around the customer, like Andy mentioned, the drive time. That is an area around the customer that represents 5 minutes drive to that customer. We could go either way. We could say, if you're the customer, how far can I get in 5 minutes? Or we can say, if you're 5 minutes away, where would you have to be to get to this customer? And that will probably look a lot clearer once we take a look at the demo. Now, when the truck starts driving along, it's trundling along and it sends its location update to the Esri function sitting in Pubnub. The Esri function talks to ArcGIS Online, figures out whether that truck is in an interesting location in the context of this set of deliveries, and fires notifications out to the delivery management app so that it can represent the truck's location on the map accurately, and also to customers when the truck is approaching them with their delivery. The last thing to mention here is security. Now, we're talking today about building enterprise apps. We're talking about secure communication both between Pubnub and the ArcGIS REST API and between the delivery management dashboard and ArcGIS Online. This is very important, and we'll show some methodologies for handling this when we take a look at the Pubnub APIs. Now, again, the JavaScript API our JavaScript API talking to ArcGIS Online takes care of a lot of that for us, and we'll show how we take care of it when we're talking directly from Esri, the Esri function in Pubnub to ArcGIS Online. So let's take a look at some real code working. Here on the right-hand side, we've got the delivery management app. Now, this has a set of customers on it. We're going to pick 5 randomly, and we're going to generate an optimal route between them. On the left-hand side, we've built a simulator because we don't actually have drivers out in the field. So when we create this route, on the right-hand side, you'll see the route appear with a set of drive time areas around it. And this blue moving dot here is the simulated driver location. On the left, you can see the driver being simulated along. And once a second, that driver fires a notification to the Pubnub block that says, here's my current location. Now, on the right-hand side, you see these light-colored areas. These are the drive time service areas, and you can see the highlighted one means that Pubnub has just recognized that we've got into the area for the next delivery. Now, in this case, we've got 2 deliveries really close to each other. So as soon as the driver left that last delivery, they were within the 5-minute area for the next one. That won't happen on this next delivery up here. We can see the ETA was about 10 minutes, and of course this is sped up. 1 second interval is perfectly fine for the granularity in the real world. Here we're speeding everything up so that we don't just sit around watching the dot move very, very slowly. On the left-hand side now, I'm just going to switch over to the console here. and we can see a little bit of feedback from PubNub. So here in the console at the bottom, we can see we've got some events being fired by PubNub. This delivery imminent event is being fired by the PubNub function in the cloud. It's taken a look at the driver's current location, realized that they've just entered that 5-minute drive time zone, and it fires a notification which our dashboard app here displays. So let's take a look at PubNub working on this as well. So if we refresh our PubNub page here, so here's my active block or function with our code, and let's start another route here. So the driver is currently on the Upper East Side of Manhattan. They got a first delivery around 74th Street, and we can see these location updates coming in from the driver to PubNub. And here, if we turn off some of these other notifications, you can see the PubNub block just figured out there's a delivery imminent on this route, and it's the first delivery. So let's take a look at some code now and take a look at what's actually happening behind the scenes. I want to start just very briefly with what it takes to put a map up in that web display. So we saw that map with the dots and the lines and the drive time areas and the moving driver on it. Setting up that map is as simple as just saying, okay, I've got a new map. This is the base map that I want, and here are the layers that I want. We had deliveries, we had those delivery fences, those are the drive time areas. We saw the route and we saw the customer. We've got an HTML element that we want to put that map into, so we have full control over the size of the map in the web browser. We say, let's put this map with this content into this div, let's center it at this Latin long, and let's just zoom to level 12. So it's pretty straightforward to put a map in there. I want to jump down to some PubNub code now and take a look at what's happening when we get those PubNub notifications. So here we've added a listener to our PubNub object. We created this PubNub delivery with our publish and subscribe keys from the PubNub function, and we're adding a listener here. And the listener is going to say, okay, did we get a delivery imminent event? If we did, let's pull out some information about that delivery, and let's figure out how to display that that delivery is imminent. So primarily, we're doing a couple of things here. We're setting some text here in the panel. Let's just jump back and see. So right now it says all deliveries completed. Up here, previously it had the next customer. Like here we go. So we can see some information on the customer. And then this bit of code here figures out, okay, for this route and this sequence, we know the delivery is imminent. Let's change the color of that outline area just a little bit for it. And that was what was happening up here. We'll see this area be highlighted to say that we're about 5 minutes away. And you can see the text up here changing to arriving soon. Let's take a look at the PubNub function now, which is probably of most interest to a lot of folks here. So the first thing I want to note is that we're taking advantage of a client's ID and client secret. So when you create an ArcGIS online application, as part of your account, you can create an OAuth application, client ID and client secret. Now, you would never put these in a JavaScript browser application, but this, remember, is sitting in PubNub's secure cloud. So it's okay to put this kind of embed this kind of information into this JavaScript here. This allows PubNub to generate a token to securely communicate with ArcGIS Online. And it's going to communicate to ArcGIS Online against REST services based off this URL. So we have a REST service for the geofences and a REST service for the user URL. Most of what we're looking at right here is actually just being a good citizen and making sure that the parameters that we were passed in to our PubNub function actually make sense for what we want to do. And we return feedback to the user telling them if they've passed incorrect information in. Now, before we do any work with ArcGIS Online, we take the new lat long of the driver and we broadcast it out. So we're using PubNub's real-time framework here already to take the driver's location, which they pushed into this function, and push it out to any interested parties. In our case, from what we've seen today, that interested party is purely the management app that we've been looking at. but there could be other back-end dashboards. There could be managers who are interested in this kind of stuff, as well as dispatchers. And PubNub makes it very, very easy to just tap into that as long as you understand what you're looking for. Now we start to talk about talking to ArcGIS Online and getting some information from there. The first thing we do is we take that client ID and client secret that we saw, and we call a get token function. We can take a look at that in a bit, but all it does is hit a well-known REST endpoint with the client ID and client secret, and that returns a token that validates communication to a specific set of data sources in ArcGIS Online. So that client ID, client secret is tied to a user or a user account, and that user account has certain permissions for various tables in the cloud. Now, the logic for what we're doing in the block here is twofold, really. We're going to need to find out where we knew that what we're trying to achieve is figure out whether the driver just got to within 5 minutes of a customer. That's represented by that drive time area. So first thing we do is find out where they were last time we knew where they were. Then we get where they are now, and this is in the context of those geofences. And very simply, we just do a little bit of set arithmetic on this to figure out, did they enter any fences? Did they leave any fences? And in this case, we're paring it down even further, saying we're only interested in that one fence for the next customer that we're delivering to. If they happen to enter that fence, then we publish a PubNub delivery imminent event. And that fires off on the channel. We saw in the previous file where the dashboard application listened to that and changed its appearance. And the last thing we do is we actually write the driver's current location out to ArcGIS Online so that we have a full track of where the driver's been and where the driver is at this moment. Now, these services, the outline, the driver's location, the route, and so on, these are hosted in what's called a feature service in ArcGIS Online. A feature we consider to be a spatial object. It's basically a database table in the cloud with a REST endpoint on it that happens to have geospatial capabilities associated with it. And that's all the communication that's going on here with ArcGIS Online. So we can take a look here at what we do when we've got this delivery imminent thing. So within the PubNub function here, we don't have to worry about setting up the PubNub publish and subscribe keys because they're inherited by the context that the function runs in. So all we have to do is set up a channel here, and we set up a couple of channels, delivery imminent and delivery imminent with a sequence. So we're setting up channels that are specific to this delivery set and this route. And we just publish those messages on there. The driver ID, the route ID, the sequence, and a quick message. We publish here, we publish one for the route as a whole and one for that specific delivery. So we can narrow down to individual customers and control what alerts they're going to get. And these messages are then handled by PubNub and fired off with extremely low latency out to their recipients. It's a very powerful model. It's worked really, really well in our example here. And the last thing I wanted to show really quickly was just an example of the XHR request. So here we're saying we want to get the fences for our current location. Remember earlier this was part of that set arithmetic. Where are we now in the context of this set of deliveries? And we don't have a JavaScript API here for our own stuff. We don't have the Esri JavaScript API. So we're going to do raw REST requests. So we had the URL, we can throw a query on here, and this is all going to be available in a repo, by the way. In fact, it already is, and we'll hand out the URL to the repo later. And you'll be able to go in and see exactly what these JSON requests look like. With a little bit of effort, you can set up your own environment to run all this stuff. The last thing I want to look at, really, is how we generated that route in the first place. So the logic back in the dashboard app now is to go ahead and when we get given a driver ID and a set of customer IDs, if you think back to the very original bit of the explanation of the problem solution in the architecture, that order management system is merely going to hand us some IDs. Let's say these customers need to get these deliveries, this driver has these deliveries, figure it all out for me, please. So the first thing we do, we've got a really simple chain of operations here. This function here is going to take that driver and those customers and get the optimal result. We then save it back up to ArcGIS Online for reference. We then figure out those delivery zones, and we save those for reference as well. And finally, we respond to PubNub saying this stuff has happened. Let's get on with things. So I'm just going to jump down a little bit to just take a quick look at how easy it is when we've got the API there, our JavaScript API, to actually make that optimized route request. We simply point at a service at arcgis.com. We say we want the driver and the customers to be the stops here. Now the driver is first, and then we'll take the customers in any order, please. And then we set up some parameters. We want the best sequence, but we want to make sure that the driver is the first stop in that sequence. We want directions, we want routes, and we also we're passing in that first set of stops, so all the driver and customer locations, and then we solve it, and that's it. And the result of that solve is a set of graphics, turn-by-turn directions, and the customers all in their optimal order. And if I've just got a little bit of time left, which I think I do, we can take a look at getting those drive time areas. So at an abstract level, we call this a service area task. And again, it's really simple. We point it at the URL. We say, here are our customers. We call this a feature set. Remember, a feature is a geographic location. So we just populate a feature set with a set of customers, or deliveries in this case. And then we just set some parameters. Now this is interesting, the to facility. That's saying we want 5 minutes boundary towards the customer, not away from the customer. Various use cases require different things in this case. So in an emergency response, for example, you might want to know how far a fire truck can get in 5 minutes. In this case, we want to know where is the 5-minute boundary for getting here. And the rest of it is pretty much just a little bit of prettiness. And we do a service area solve. The result we get back is a set of geographic buffers that we can put onto the map. So that was the demo and all I had to show you. Just to summarize what I covered, we talked about optimized directions. And again, remember, there are no servers involved here. This is cloud-based, just purely cloud-based solutions. We took that drive time area and turned it into a geofence that we used for triggering certain events. And PubNub's real-time stuff with the Esri function handled that triggering. We saw real-time vehicle tracking going on. I covered just at a very high level. We didn't really go into the details, but the GitHub repo covers it, secure token-based stuff. And I just touched on some of our niceties as part of the JavaScript mapping API. So with that, I'd like to hand back to Grace. And
all right,
thanks.
Yeah,
webinar. Thanks, Grace.
Are you guys all able to see my screen?
Yep.
Cool, awesome. So I just want to thank Nick really quickly for that awesome demo. And just to, at the end, guys, that's just one application use case that highlights the power of PubNub and Esri. But there's so many different things that you can do. At the core, though, PubNub and Esri make it super easy for developers to integrate real-time maps and geolocation into their apps and services and create exceptional user experience. So for those of you who are interested in getting your hands on the code and getting started with PubNub and Esri, for PubNub, you just go to pubnub.com/product/functions and you can see all the cool things that you can do there. Or if you want to talk to a solutions architect to kind of dive in a little bit deeper about your company's use case, feel free to reach out to me and I'm happy to help schedule a conversation with our solutions architects. And just to let you know, PubNub does have a free tier that gives you up to 100 devices and 1 million messages. So it's awesome for demos or POCs that you want to build out. But I'll let Andy kind of take over and tell you a little bit more about how to get started with Esri.
Thanks again, Grace. With Esri, sign up for a free account today at developers.arcgis.com. And for all you attendees, we're also providing that voucher code, MAPS 2017, MAPS 2017, and that's good for 1,000 credits. And one of the things that the credits will help you with is if you're uploading data, creating data, those feature services that Nick mentioned that contain geospatially enabled data. You have to sign up before August 29th, and those credits expire on March 1st of 2018, so redeem those soon. Last but not least, all the code we've shown in this demo is now available at the Esri GitHub repo, github.com/Esri. And if you just search for PubNub or go to pubnub-delivery-tracking-demo, check out the code. And back to you, Grace.
Cool. So thanks so much, everyone, for sticking through it with us to the end. We have some questions that we want to save the last 15 minutes for. So let's just get started with those. So the first question that I think is directed for Esri is, what's the pricing associated with Esri? Or how much does ArcGIS cost for developers, I guess?
Okay, I can take that one. Andy, you want me to take that? Yeah, sure. So there's two ways to subscribe to Esri's cloud solution. One is a developer-centric way, which is what I'll talk about both very quickly. The developer subscription is a monthly free subscription, starts at free. You get 50 credits for that. Now, this is talking back to the code that Andy mentioned. That gives you 1,000 credits that expire sometime next year. For free, you get 50 credits a month, and that allows you access to a bunch of services. Like the drive time services, the routing services, data storage, and so on. We don't charge for data retrieval and views. We don't charge for uploading data, but we do charge for the amount of storage that it covers. As a developer, if you find that you go over that 50 credit limit, then there is a tiered payment plan for that. But for the free tier, we don't even ask you for a credit card. You can get started and just enjoy those 50 credits a month. If you're a larger organization or an enterprise, then we have what's called an organizational subscription. It's essentially the same as the developer subscription, but it's charged at an annual rate and includes multiple named users. So we can scale the number of credits you get per year, we can scale the number of users you get per year. And the goal there is to support you as an organization with different roles within your organization for editing, viewing, creating data, and the like. And that starts at $2,500 a year for 5 users and 2,500 credits, but scales appropriately. So those are two ways to get into it. There are some nuances about the functionality and differences, but really that it's stuff like our marketplace access to some of our more sophisticated business analyst stuff is not available to the developer subscription, but the organization subscription can have access to all of that.
Cool, awesome. So a next question. Do I need to create an account with Esri and PubNub to use the blocks?
Yes, you'll need to, so the repo goes through this actually and shows some prerequisites, yes, you'll need to create a free PubNub account, a free Esri account, and between the two of those, you'll be able to get this demo up and running and start working with the blocks.
Okay, cool. The next question is, do Esri and PubNub services work worldwide? Is there any adaptation that should be made for the services to work in cities and countries around the world?
It's a very
You guys
good
can
question.
answer for the Esri part, and I can answer the PubNub.
Yeah, do you want to go first for PubNub?
Yeah, so PubNub, we have 15 points of presence all around the world, so it doesn't matter which country you're in, you'll be able to get that quarter-second latencies.
For the Esri side of things, it varies. So our services are global, but the quality of the data behind them does vary country to country. For example, China, it's very difficult at the moment to get really accurate traffic information and street network information. There are portions of Africa that are not as good quality as others. We do have maps that show you exactly the level of service that we promise for each country. But it does vary globally, not in terms of the technology and the services, but in terms of the data behind them that we need to be able to answer the questions that you ask.
Awesome. Okay, another question. I'm working on a mobile mapping application. Do you support native devices?
Yes.
Yes, we do.
we've got, Andy touched on this briefly. If you go to the developers.arcgis.com site and take a quick look there, there's SDKs and APIs listed. So we have .NET, Xamarin, native Android, native iOS, Java, also Qt.
Yeah. And for PubNub, we have 75 different SDKs, so it doesn't really matter what environment you're building on, we probably have something for you. Another question, do your API support 3D? Oh, that's interesting.
Yes, they do. We didn't show 3D, but if you go to the JavaScript API samples at developer.arcgis.com, search for 3D, we've got live demos up there. It's pretty cool stuff.
Can I use my own data with your platform, Esri?
Yes, absolutely. I mentioned feature services, and Andy talked about how you can create these hosted feature services yourself up in the ArcGIS cloud. So if you have your own data, if it's already got an XY coordinate or a lat long, it's very easy to upload it into our cloud, and it becomes this spatially enabled database with your locations. Also, if you've got GeoJSON or shapefiles, you can push them up, and then they become just another REST endpoint with data behind it, and you can just drop them into a map, analyze them, interact with them, figure out whatever you want about them. So yeah, and it's really, honestly, it's a lot of our bread and butter is providing that functionality for our customers to bring their own data into our platform and be able to use our tools against it.
Another question, does Esri have routes for ships, say in SF or other areas, and are not only restricted to roads?
That's a good question. Andy, you mind if I take this?
Go ahead.
So the short answer is, in terms of the cloud that we've been talking about today, no, we do not provide shipping routes. However, there are various different modes of transport on the cloud-based route engine. So we could have done walking directions, and in that case, stuff like the East River Ferry in New York is covered because they're considered walkable things. Now, we do have separate products that work in exactly the same way, but you bring in-house, and in that case, you take our network modeling technology and you can build your own networks around it. And a lot of our customers do shipping routing using that on-premise stuff, but it doesn't apply to the cloud-only based stuff that we talked about today.
Do I have to install any software to get started with a demo app? Oh, you kind of answered some of that.
Really, the only thing you really need is a web server, a local web server. But I'm going to update the repo as well and put some instructions in for not even needing that. So you should be able to fork the repo, update it with your PubNub credentials and your ArcGIS URLs and credentials. And the repo talks about generating those. And then be able to run it directly off GitHub off your own fork. So I'll update the repo with instructions to do that later.
Cool. Is integration with GeoEvent possible?
Yes.
I'm not you understand the question? You mean GeoEvent server, I assume, Andy?
I assume that's what that meant.
Yeah, okay.
Yes, we didn't use it in this particular example, but GeoEvent server takes what we demoed essentially to the next level. Since we just have a prototype, when you step up to a commercial application, that's probably the direction you're going to be going, if that's what the question was about. Would you agree, Nick?
Yeah, I'm assuming that's what the question was about. And for everyone who doesn't know what GeoEvent server is, it's another one of the products that we have, not cloud-based, again on-premise, that can handle vast quantities of real-time geospatial updates. And customers bring that in-house, tweak it to all sorts of levels and base solutions based off that. But again, because everything is REST-based communication, you can take a lot of the components of what we talked about today, integrate it with GeoEvent server, and run with that.
That's right, and I wanted to tag a note onto the end of that. As you scale up your solution to hundreds or even thousands of vehicles, you definitely need that enterprise scale in order to handle the volume, to handle the complex routing calculations. And it even goes further. You can take into account interesting things like the angle of the road, the weather, height and weight and width road restrictions. So we really did just touch the surface of what's possible. And as Nick mentioned, Geofence takes that to a whole new level.
All right, I like this question. Are there any future webinars planned for Esri and PubNub? Found this really interesting. Yes, I definitely hope so.
I think we have to make the answer yes.
Absolutely.
Okay, for another question. What's the vehicle location request interval time? How long between real-time responses?
Right, so there's a few different ways to look at that. Now you can, as you're a truck driving around in real, we saw a sped up example, right? And I deliberately limited the speed of updates to once a second. In the real world, that's probably more than accurate enough for a truck driving around a city. If you're a missile guidance system, you want way more than that. But if you're just a truck driving around the city, once a second is plenty. You also need to consider whether that GPS unit transmitting the data up to the cloud and into PubNub is attached to a battery or not, because having GPS and radio firing all the time can drain that battery really quickly. So in terms of what the back-end data sets can handle, in terms of, let's say we try to update once a second, that's absolutely fine. 1,000 times a second, well, you're going to hit all sorts of network latency issues before you start hitting data writing issues, I would imagine. So it's a sliding answer and a gray area. But in terms of what's realistic, I would say for most use cases, the solution we covered today can handle a broad range of stuff. What I'd like to also say is, and we'll make sure we get the GitHub repo out, if you have more detailed questions on this or you want to expand on any of these questions, let's open up an issue for that question and we'll try to address it in the GitHub repo as well.
Right, so we have an interesting use case specific, or not really use case, but an example question, and it asks, where did it go? Let's say there are multiple users, around 100 plus, at the same time using this real-time app that you built. At every 1 minute, new location publishes using PubNub. So does this increase the publish and subscribe messages in PubNub?
Let's see.
Nick, do you want to take that one?
Yeah, let me try and understand it. Let's say I'm reading the question again. Same time using a real-time app and every 1 minute new location. Well, in building this, we've been really liberal with the publish and subscribe messages, and there are ways that we could pare that down. We've focused in building this on being as responsive to the various components as we can. I would answer that by saying that it's up to you to look at your use case and minimize the publish and subscribe messages as much as possible. So the one thing you can't change based off your use case is how often you publish the location to PubNub. That needs to be minimally supportive of what you want to do. Beyond that, you could use some logic in the KV store, for example, on the back end of PubNub to queue up outgoing messages from PubNub and alter that appropriately.
Yeah,
and I think, sorry.
No, go ahead, Nick.
Yeah, I was just going to finish by saying it's quite possible that using some Pubnub function chaining could really help in that regard as well.
So that's a great question for our solutions architects. That's essentially why they're here with us at PubNub. They're the best resources in terms of helping you architect the best way to minimize messages and to be effective with how you publish and subscribe. So whoever asked that question, I'm happy to kind of connect you with Bhavna or any of our other solutions architects to do a little bit more deep dive.
I see another question here about indoor mapping.
Oh yeah, go for it.
Which I'll just address really quickly. Yes, our platform does support it. At the moment, people are still settling on the best way to actually determine location indoors. So there are various beacon-based solutions and Wi-Fi triangulation-based solutions. But if you can get that location, then our platform handles it very well. And in fact, we're used in a number of indoor locations. Schiphol Airport have been using us. I think they have an application deployed to tens of millions of users that allows them to navigate internally. We've got a couple of startups in our startup program that are focusing on indoor navigation as well. And in fact, at our once a year we host a large conference in San Diego, and this year we actually enabled indoor mapping for that and had a couple of sample apps based off that, and that worked really well.
Very cool. Oh, quick question, Andy or Nick. Someone has tried to use the code MAPS 2017, but they weren't able to enter that code anywhere on the Esri account they just tried to create. Where can they go?
Oh, yes.
Yeah.
When you log in the upper right-hand corner where it says your name, there's a down arrow. And if you click on that down arrow in the upper right-hand corner, you should see the second option is redeem voucher, and that should get you where you need to be.
Okay. Question about the demo. Where's the data stored for driver's route? Is it the stored in the cloud or interaction or locally on the driver's side?
Right. So we took an approach here where we store the route once it's generated. The turn-by-turn directions are generated. We store it in ArcGIS Online for reference. But the key thing in this use case really is not so much that the driver follow that route, but that they have that they go to the customers in the right order, in the optimal order. So it's quite possible that while we might use our route calculation to say this is the order that your customers need to get their deliveries, the driver can use a local direction finding system to figure out their own directions. Now it depends entirely on the use case. If you're a municipal fire department, you might have your own on-vehicle routing solution that's robust and doesn't depend on connectivity in any way. If you're Uber or Lyft, every Uber and Lyft I've got in recently, they don't even use the Uber app. They use whatever suits them at the time. Some of them have an old GPS stuck on the dashboard. So in terms of getting between points, we've left that deliberately open in this example. But we do store the calculated route for reference. And in fact, I use that in the simulator as well.
Are these tools being used for urban distribution or long-haul services?
Both.
Same on PubNub side, both. We have customer examples of, very, very much, basically everyone else but Uber, all of Uber's competitors have used PubNub to a degree. So those are the examples of urban distribution, but we also have some of the bigger logistics companies using us as well. So both.
And I'm going to add one thing to that as well on the Esri ArcGIS side is in terms of what is the goal for using these types of services, and yes, they're definitely used with commercial trucking and delivery firms like real-time delivery and those things. The end goal is to save time and money and wear and tear, because you're giving the most optimal route for one vehicle that has multiple delivery points. And the end goal is to reduce the number of miles that truck has to drive, get them there in the fastest amount of time. So you're not only are you saving money on salaries, you're also reducing wear and tear on the vehicles by not having them unnecessarily drive where they don't need to go. And the cost of diesel fuel on these commercial trucks can really add up.
All right, I think this is going to be our last question for today. Can you explain the Geo Enrichment block a bit further? Does the Geo Enrichment block provide the demographic data sources, such as population by city region, or does this just offer the ability to add your own data?
Andy, do you want me to take that, or you got it?
Sure, I can jump on that one. The Geo Enrichment block, and I'm assuming this is the one that's currently published on the PubNub blocks page. Yes, that does provide demographic data sources from Esri, and reading the questions such as population by city and region. Yes, it goes all the way down to a block group, and for those who are listening, if you think of an area such as a zip code, block group can be smaller than a zip code. It's the finest level of granularity that you can go down to for demographic information. And yes, you can also add your own data to this. I wanted to add that maybe Nick knows the exact amount. There's literally hundreds of demographic variables that you can access, and we just picked a few for that geo enrichment block because exposing all of them would consume a lot of bandwidth, so we just picked a few. That information is also available at developers.arcgis.com. If you aren't able to find it, just go ahead and open an issue on our GitHub repo at github.com/Esri.
Yeah, a couple of things I'd like to add about the geo enrichment stuff. So it's built upon a very rich data set that we collect globally. Now, the richest, just like the capabilities for routing and the like, this varies country by country. But our data analytics team does the best as it can with the various sources. Some of them census sources, some of the commercial sources. So it changes by country. In the US, there's thousands of data points that you can query. The other thing I wanted to cover was that geo-enrichment is an API that exposes this data set. If you're really interested in integrating your own data with it, which, for example, Starbucks uses as part of the story that Andy was telling earlier, you can buy that data, and we have a different product. It's called Business Analyst, and you can combine. And in fact, there's a few different products that take advantage of this data and allow you to use it in different ways, either on-premise or in the cloud. So it really depends on your use case, but there's flexibility to integrate your own data there as well.
All right, guys, I know we have a few more remaining questions, but we're going to have to put those on hold. Like Andy said, and as Nick said, you're more than welcome to reach out to us individually at our emails here or on the GitHub repo that they have. And for any of you guys who have further questions, want a little bit more deep dive, please let me know. I'm happy to introduce you to our solutions architects for some of those more use case specific questions. So with that, I just want to thank all of you guys for joining us today, and especially for Andy and Nick from Esri for giving us that awesome demo. This has been a lot of fun. I hope you guys enjoyed it. Hope you guys all have a great day. And don't forget, tomorrow I'll be sending out the email with the recording. So if you have any questions, just reach out to me, Andy or Nick. Thank you all, and that concludes our webinar for today.
Thanks, everyone. Thanks, PubNub, for hosting. Yeah.
Ditto.